Hey, here we are, everyone. So we are in a bright, shiny new packet, Unit 4, topics A through C. There's a lot of modification that goes on through here, a little bouncing around that we're going to be doing. Don't worry, we'll guide you through it all and get you there. So when you open up, don't be scared. Don't be scared. Yes, we are starting off with lesson number 8. Um, we are in your classwork packet. Let me rewind that as well, too. Yeah, today we're going to jump right in. We're going to do classwork together. These are talking about your properties. So these are things that are always true in math problems. And as much as it seems like it's common sense, like 2 plus 3 is 5, but if you flip it around, 3 plus 2 is also 5. Yeah. So what we're going to be looking at are things that always happen. We give names to them. All right. So like I said, vocabulary-ish words kind of day we're looking at. So um, let's go through it. Your commutative property. Your commutative property is when you simply flip the order around. That was the idea of what I just did there. Commutative property of addition. So that's saying is if you take a number like 3, all right, and you add 8 onto it, it's going to be the exact same thing as if you started with 8 and then you added 3 onto it. See, with addition, the order doesn't make a difference. You're going to get the exact same answer. So that's what the commutative property of addition says. Add two numbers, you can flip them around, it's not going to make a difference. All right. Now, question 2, demonstrate the commutative property of multiplication. Okay. Also with multiplication, if we take the number 3, all right, and then we multiply it, all right, by the number 8. That would be the exact same thing as if we started with 8 and then we multiplied it by the number 3. Multiplication, we can also flip the order around. Now, we're not going to be talking about subtraction here because if you flip the order around subtraction, it doesn't work, all right? 10 minus 7 is not the exact same as starting with 7 and then taking away 10. Division, taking 24 and dividing it by 8 is not the same thing as starting with 8 and dividing it into 24 groups. So that's part of the reason why we see this is because it doesn't work in all situations. All right, additive identity. All right, additive identity property of 0. So what that kind of says here is, hey, did you know if you take a number like 9 and you add on 0 to it, nothing happens. You get the same thing all over again. Yeah, that's why it's identity. Identity yourself. You're getting the same thing. So if you add 0 onto something, nothing's going to change it. Um, I know. Like I said, we're just giving names to things that always occur. Demonstrate the multiplicative. One of my favorite words to say. Multiplicative, parallelogram. All right. Yeah, those are tops there. So multiplicative identity property of 1 says if you multiply a number times 1, it won't change it. So kind of what we're saying here is, hey, how do you keep numbers the same? Well, if you're multiplying, times it by 1. If you're adding, we're going to add a 0 onto it. Like I said, we're giving names to things. All right, so now let's see if we can get some examples here. Commutative, all right, remember commutative properties where we just flip the order around. So instead of 25 plus 12, you'll say 12 plus 25. Yeah, we're just gonna flip it around. All right, it's a bad looking 12 that we got there, isn't it? Okay. So if we look at commutative property of multiplication, remember, commutative means that we're just gonna flip it around. So I've given up on the 12. All right. We're gonna take that 2 this time, all right, and then we're going to times it by a 7. So again, flipping the order around. Additive identity property 0. So we want to finish with the 12, which means what would you add on so that you would get a 12? Well, 0. We would add nothing on. And then what would you multiplicative identity? What would you multiply by so that you get a 9? Well, we would multiply by 1. All right. Like I said, giving names to things here, giving names to things. All right, so demonstrate the commutative property of addition using variables. So we're just using letters. Okay, no big deal. Remember, commutative just means we can flip the order around. So what they're saying here is hey, if you take 2 items and add them together, it would be the exact same thing as if you flip the order around. That's it. So letters just mean general sense. It means you can use whatever numbers you want. You want to use a 9 and a 7? Fine. 9 plus 7 is the same as 7 plus 9. Wait, you want to use a 13 and a 61? Fine. 13 plus 61 is the same as 61 plus 13. Again, the letters just mean it can work for all of our numbers. Commutative property of multiplication. Remember, when we multiply numbers and letters, we like them right up against each other. So there you go. Again, flipping the order around. Demonstrate the additive property of 0 with the letter B. Okay, so again, if we add on 0, what happens? Nothing. All right, we get the exact same thing all over again. Demonstrate the multiplicative identity property. Okay, multiply to get itself. So if you take the number B and you multiply it by a 1, you get yourself right back. What we don't want to say is times it by a 0. Or if we're doing the additive identity, we don't want to say, ooh, let's add a 1, because again, that's not going to get the same thing back. All right, so demonstrate the property listed in the column by filling in the third one there. Okay, commutative. Remember, commutative means to flip the order. So instead of 25 plus C, C plus 25, flip the order. Not a fan of the multiplication symbol here. Just want to point that out there. Commutative, again, flipping the order. W times L. Additive, what happens when you add 0 onto something? Nothing. We just get H. Multiplicative identity, what happens when you multiply by a 1? Nothing. We just get our. All right. And then the last part they're asking here is, why is there no commutative property of subtraction or division? Okay, so this is kind of what we talked about at the beginning. And the main reason why isn't there is that because it doesn't work. All right. Well, what do you mean by it doesn't work? Well, we don't get the same answer. All right. For example, if you take a 4 and you take away 1, you're going to end up with a 3. But if you flip the order around, you start at 1, and if you go to your number line and you start at 1 and you count 4 spots back to the left, you don't land on 3. You actually land on -3. Again, not the same answers. If you take the number 24 and you divide it by 8, you're taking 24 and you're breaking it up into 8 groups. That means there's 3 in each group. But if you take the number 8 and divide it by 24, you're starting with 8 and you're breaking it up into 24 groups. You're going to be smaller than 1. This is why we call it a fraction. This is why we use that fraction bar. That's why division symbols are simply a fraction bar. We're going to divide them both by 8. We can just clean it up. We get 1/3. So again, think about it as as candy if you want. I got 24 pieces of candy to share with 8 people. Hey, we're all going to get more than 1 piece of candy. But if I only have 8 pieces of candy and I got to share it with 24 people, we're not even going to get 1 piece each. So that's what we're doing there. All right, everyone. That's it. All right. Enjoy.